Hi everyone, welcome back to this Kinetic Rain, Grasshopper, and VRay tutorial series. Now with the introduction of the previous video out of the way, we can finally start. And we'll start by making the raindrop model. Now I searched around on the internet and I found two mathematical equations that allows us to create a uh, very accurate looking raindrop model. So we'll just type that into our canvas. So to start, well, not that, let's open up a expression editor. It doesn't really matter which one we choose. I choose this expression editor because we can see the formula right here. You can also use the evaluate command, which is this one, but the difference is instead of putting it here, we can put in a yellow text here, which does exactly the same thing. So um, there's really no difference between which one you want to choose. So for the simplicity, I chose for this one. It saves me a yellow panel. So we have that. Unfortunately, I don't really know how to explain the formula that I'm going to type in, so you just have to type along with me. All right, so we open a bracket and then we take in the x input times two more brackets inside because this will be calculated first. 1 minus the sine over y, and then at the end we're going to close these brackets. So that will be, this bracket is for that. So we have one more bracket to close for this one. Now that we're going to times the cosine on y. Oops, that's not y. So we'll press OK. Of course, it's gonna get errors because we have no input whatsoever. So let's give it an error. Let's not give it an error. Let's give it an input. You can experiment this later on, but we'll just start with the default value. So I'm just gonna type in 1.0, sorry. You can actually increase that. Maybe let's increase that for now. Let's say maximum of 5. So we'll put that in here. And then for the y value, this is going to be a little bit trickier. This is also a value that I found through trial and error. For this, I will create a panel. Okay, so a panel that just to quickly make a domain 1 to 3. So this is going to be a domain, and we're going to make a range actually because we want to have a few numbers. We're gonna have a few numbers between the domain 1 to 3 and the amount of numbers we want. Let's start with 10 because this doesn't really matter as much as you will see later on. And then what we're gonna do here, we're gonna get our pi number because the numbers, let me just put a table here so you can see what we're doing. So we got 10 numbers, 10 steps from 1 to 3, as you can see here. We're gonna plug that into pi. But before, and now the numbers becomes this. Now before we plug it into y, what we want to do is do an expression on the output, and the expression will be x divided by 2, so that all the pi is half. Now you could have done this to 1 to 1.5. I believe that will give us the same results, but either way it will work. So now that we have the first setup done, we're going to make point constructs. Let's see this one. So this will go to the x. You'll see all the points are now on one line, so they're not doing anything because we still need the y value. I will leave this here for now. Maybe I will use that later on. I'm going to copy this, but I'm not going to be using the same formula. Actually, I'm going to be making a different formula, and that will be x times, open brackets, sine y. Oops. Let me close this bracket. Sine y, sine is y, and then this whole thing minus 1. And as for this, we'll create a different variable. We'll name this 3.0. We'll put this in here. And then you can plug this one to the y coordinates. So what you'll see here is a nice half droplet. And now the only thing we need to do is to mirror this. Well, actually, we're not going to be mirroring this. It's best to just revolve it, and then we'll have our droplets. So with that said, we can delete this one because we don't need that one. After we've done all, we can play with the parameter and see which one does what. So first off, to revolve, I need a axis because the revolve command or the revolution command needs the profile curve, which we'll create actually right now. So we're going to make an interpolated curve, which will be this one. So we draw that. We don't need to see this now. You can see that's quite a nice looking half of a droplet. And this will go in here. And the A, before I go on, I found one nifty little things, which is the bifocals, which would, as you can see right now, allows you to see what the component names are. Because I prefer to use the icon, that's how I recognize what they are. And for people who prefer to have the full draw name like this, well, it's just very messy. Hence, I tend to turn that off. So with this, I hope I will be able to bridge some gaps so that you can also follow along a little bit easier. All right, so we have the A, which is the axis. Obviously, we want the middle axis, which is going to be a Y. So creating an axis, what we're going to do is we're going to create a line. We're going to create a vertical, an SDL line. So we're going to make this. So this one takes in a point, direction, and the length. The length doesn't really matter. So we just need the S and the D input. We know that from these points, if we were to take, doesn't really matter which one, we'll just take the first one, will be the top one. So that's going to be a starting line. And then we're going to go Y because that's the direction counting from that. And we can plug this in here. And as you can see, we don't even need to do the angle because the angle defaults to 360 degrees. So if we rotate around, you can see that's what the drop looks like. And now we can sort this a little bit like that, like so. Is there any option I can change? No, okay. Never mind. All right, so now we can see what do these value actually do. So if we increase this, we can see it gets wider, right? So we can default this back to 1. You can call this the width. And as for the steps, I need to turn on the points to show you what's going on. These basically dictates how many points will it take to make that droplet. As you can see, even 5 is still okay, but be careful when you go too little for the steps. You can see that a droplet now suddenly has a very pointy end. So I generally found that with 10, which does a little bit better job at rounding that corner and rounding that point. So that's why I kept this at 10. You can actually hard code this in as a panel so that you don't accidentally change it, because we are never going to change that. And as for this one, you can see this one controls the stretchiness on that angle, on that direction. So we're going to call this the heights. Oops, that's not how you write it. There we go. Now, if any mathematician out there is able to explain this, do type that into the comment section and I will read on it. I forgot where I found this, to be honest. I'm not even sure what I look for in the Google search. I turn up with these formulas. It's been a while. All right, so with that said, we have our revolution. There's also this one last step before we round up our droplets model, which is now it's actually sitting on, because if I turn on perspective, if we treat the Z axis as the vertical axis, it's now sitting on its edge, and droplets don't fall that way. So we need to reorientate this droplets so that it's vertical. And the one thing to do that is to choose a orient. So the base geometry we want to orient is that one. And right now it's sitting on a XY plane. So we're going to open that up. And we do need to specify where the plane is. Well, since it's in the middle, it doesn't really matter. Since it's in the origin, sorry, it doesn't really matter. But just to be sure, let's connect the point that we use for the line, same for the point, same for the plane, so that we can say A, which is the initial plane, which it already has a default plane which suits our plane. But just to make sure, we're gonna make that plug that in here so that whenever we change something here, nothing will go wrong, or at least we can be absolutely sure that nothing will go wrong. Now we want to orient this to vertical, so that would mean that we need to have the XZ plane, right? So we're gonna take that and we're gonna orient that like this, and we're gonna turn off everything else, and then we have our droplets. So, but this is a surface. I found that during the making of the original script that if you convert everything to a mesh, the steps that comes after this will be significantly faster. So that's what we're gonna do. We're gonna mesh this whole thing. Just a simple mesh. Let's see how that turns out. I mean, it's quite detailed, seeing we have about 18, almost 1900 vertices. So you can probably play around with the mesh options, but I think most modern computers should be able to handle this. Unless in the later stage you are really going to do 1000 by 1000 droplets, then we have a problem. But if you've seen the introduction video, I've also included in the later steps some reduction switches that we can use while we're making this model before we animate it. So that should be all right. All right, so let's hide that. I'm gonna press F7 to hide the plane on my Rhino. Right, so like I said, there are two outputs that we need. One is this one, and the other one is the point on which it will attach. So I'm just gonna quickly do point, and it just so happens that this point is exactly the point that I need to attach the wires coming in. So I'm gonna rename this. I'm gonna call this attach PT for attach point. Well, I'm not gonna copy that. I'm just gonna say geometry. I can say mesh, I guess. Doesn't really matter which one. So let's take the mesh then, and we'll tell this droplet mesh. You can hide these. So now we know that these two will be what we're going to be using in the later stages. At this point, what we can do is we can add a scaling factor into this. So let's say we want to have very big droplets, or we want to have very small droplets. You could play around with these two, but then you have to find a way to make sure that whatever ratio you have here, which is now 1:3, is always going to be the same. I found it easier to just let's just put a scale to it. So let's say 0.5 to 3 should be enough, I guess. Let me just call this scale. So we're going to scale component. The scale factor goes to the F, and we're going to connect this, let's say, after the whole thing is rotated. The G goes for the geometry. Now the C is the center point. We want it to scale from the attach point, which will be this one right here. So we're going to put that in here. As you can see already, in my preview, we have a droplet that's twice as small because I've used a initial scale of 0.5. So let me put this to 1 so that it overlaps, and then we just replace the mesh with this one, and now we have a scale within our droplets. Let's just make a scribble. So we'll call this droplet model. Oops, droplets. Seems like I can't type at all. We'll make it a little bit bigger. That's, I don't know, how much is 80? Yeah, that should be enough. Oops. Is there anything else? No, okay. So we'll group that, and we have a first droplet model. In the introduction, I showed you that I also created a lamp model. So I could guide you through that one, that one is actually also quite easy to do. Maybe I'll do that, and then we can end the first part of this tutorial here, and then we just pick it up the next part, creating the grid for the starting point in the next video. All right, so let's create the lamp model. The basis for the lamp model is actually just a rectangle. Let me just start with a rectangle. And what I've done here is I basically created a domain. Let me turn on my grid so you can see what's going on. So let's create a grid because I want the origin point to be the center. Hence, I created a domain. So let's say construct a domain, and we're going to make some. Let's start with 50. Let's connect these two here. Obviously, one will be the negative, so I'm just going to right-click on the A expression minus X, so that I can put this to this one. Not that. Where is my model? Oh, right. I just need to also for the Y. Oh, that looks a little bit too big. We'll scale that down by a lot. All right. Actually, I think my droplets might be too little because now I'm in millimeters, and this is like what? Let's see. It's like 7 mil. I mean, could be. We'll see what's up. We'll also include let's put this to 5 at the moment. We also have a scaling for this one, so that should be all right. Okay, so with this made, the next step is quite simple. What we're going to do is we're going to offset the curve. So we're going to put this one here, and our offset distance, going to just start with 0.1 with a maximum of 2. I think we can leave this at 1. Yeah, that may be too little, so I need to increase this a little bit more, so like that. We'll scale this back down in the end, but I guess 1 mil as thickness for paper should be doable, although you can down this to even more. Oh, I think I've set so let's say 0.2 is the minimum. If you do go 3.2, which is still doable, so we'll just leave it at that then. That looks a little bit more realistic. So I do think that our droplets needs to scale up a little bit more in the end, but we'll see. Right. So as I was saying, we have offsetted curve. The next thing is to simply we will actually boundary surface this first. Well, actually, I don't think we need a thickness for the for this one, because if we're going to render it in VRay, we can just apply material that has a back end and a front end. So apologies, we'll just have to get rid of this. We don't need this. We just extrude this. Well, not extrude the point, but we do extrude this one. We're going to obviously extruding downward, so that's the Z axis, and we're going to extrude, I don't know, 100 to 500 and see which one fits. Now, obviously, we're going to extrude downward, so right click on the F expression and then minus X. This kind of looks okay for a lamp, so we'll leave it at that for now. The next thing is to create the attachment for the grid, because if we make nothing, then it will look like the string that will come attached here is going to be floating somewhere, and we probably don't want that. This is all minor details, but I prefer to have this one done. So what I'm going to do quickly is to make a discontinuity from this one so that I can get the 4 corner points, right? And then what I'm going to do is take an area, because I want the center point for that. You can also do average, I believe, or just center, but I've gotten used to using area, or you can just use the original point since it does come from an origin point, which is similar. But this one means that whatever you put this, doesn't matter, I always get the center of my rectangle, or actually square. With that being said, let's make a line of 2 points, obviously from the C to the P, so we got that one. And now what you can also do, you can move this down, so you have also the exact same line for the bottom. So let's do that also. So we're going to move this with the same value that we have here. All right. Now we can first mesh our extrude, which will be this one. We can hide that. We don't need to see all this now. The next one, you can mesh our pipes. So we are going to mesh those two. Mesh pipe. I do think that this is a separate component that I downloaded. I forgot, but if you have issues finding this component in your Grasshopper, let me know. I think this is from its separate component. If you can't find it here, then it's probably downloaded from the Grasshopper3D.com website. So let's put this in here. Let's put that one in there too. Now, obviously, that's way too thick. So I'm just going to create 0.1 smaller than 0.5. Let's see, and connect it to the R. Let's see which one give us a better, oops. I think, like to imitate small metal strings. All right, let's go to 1. All right, this looks okay. So now what we're going to do is just combine this together. So we're going to do mesh join. We are going to flatten this part. We'll go here, here. We have one mesh model. So we can actually, well, it's not called Droplet. So let's make our own here. We'll call this lamp model. Actually, what did I call there? Droplet mesh. Oh, I should probably call this lamp mesh. Let's put this down a little bit. And now we need the attach point, which is the center right there. So we're gonna say point. Actually, let me just go fast because I don't want to rename. Just copy that one, plug this one in here, and we have our points. And I'm gonna copy the title too. So this will be lamp model. Now, the final thing that we're going to do is we're going to build in a switch so that we can toggle between droplet and lamp. Or if you have more, you can create even more switches. But since I only have two, what I can do is just create a toggle. Otherwise, you have to probably do a value list and then do a cycle or drop down, and then you can select which one you want. Since the toggle it's false is 0 and true is 1, I'm just going to use this one. And then in the end, we can do the filter gate. If you have more, like I said, you can zoom in, you can click on this plus signs to add your different models to it. So this one goes here. Now it's true, so meaning whatever comes in 1 will be outputted by the S on the output as denoted. So if I go to false, which will be this one, I'm going to create one more because one will be for the droplet attach points, just the attach point. The other one will be for the mesh itself. So the first one is going to be, if it's false, it will take the droplet. If it's true, it will take the lamp. So I'm going to do the same here, there. I should don't know where to put this. Well, just we need to call this something. What is it? Model selector. Oh, yeah, we'll just call it a model selector, and then we'll add that to the group. I could hide these arrows, but I think these are always going to be together, so not too concerned about that. But what I will do is make it neater by adding it like this. So I'm just gonna call this mesh model, and then put this here because I want whatever comes afterwards from these two and not from these S. It doesn't really matter a lot, just maybe a little bit cleaner. Okay, I think for now you can save this file, and then in the next part we're gonna be generating the grid of how many points, how many droplets, or how many lamps you want to have. So with that said, I'll see you in the next video.